Assalamualaikum warahmatullahi wabarakatuh. Grade 11, this is a video lesson recording for Statistics and Probability, Module 3, Sampling and Sampling Distribution. Last time we were talking about normal distribution, and we talked about what is normal distribution, the shape of the normal distribution, different characteristics of the normal curve, also identifying the areas under the normal curve, and then how to get the standard score from the raw scores, and also talking about the probability and percentile rank in normal distribution. Now, for this module, we are going to talk about sampling and sampling distribution. The most essential learning competencies for this module are illustrate random sampling, distinguish between parameter and statistic, identify sampling distributions of a statistic, find the mean and variance of the sampling distribution of the sample mean, define the sampling distribution of the sample mean for normal population when the variance is A, known, and B, unknown. Illustrate the central limit theorem, and define the sampling distribution of the sample mean using the central limit theorem, and finally, solve problems involving sampling distributions of the sample mean. Now, this module is subdivided into 5 lessons. So for this first video, part 1, we are just going to talk about lesson 1 and lesson 2, which is basically like an introduction of the entire module. Okay? So lesson 1, random sampling. Let's analyze this first. Analyze and compare the following cases. Case 1. Mrs. Salim wants to do an analysis on students' final examination scores in her 40 grade 11 mathematics class for the semester. Should she consider all the students' scores or only some of the students' scores? Case 2. A group of researchers want to determine the average mathematics grade for the semester of grade 11 students in the Philippines. Should the group consider conducting a survey to all the grade 11 students in the Philippines or random students of selected places only? So if you're going to look at it, the first case, you can actually include all of the students because 40 lang naman sila. It's not that big of a number. Okay, but on case number 2, if you're talking about all of the grade 11 students in the Philippines, you may be talking more than 50,000, 100,000 students. So you can never submit or ensure that you can give questionnaire to all of the grade 11 students in the Philippines, as well as all of the grade 11 students will return the survey with answers to you. So it's probably a practical thing to do for the case number 2 to only include a few students who are selected from different schools in the Philippines. So before we talk about random sampling, let's talk about population and the sample. Population is the group you want to generalize. It consists of all the members of the group you are interested in. Sample is the subset from the population you want to examine. So, the sample group comes from the population. A well-chosen sample will contain most of the information about a particular population parameter, but the relation between the sample and the population must be such as to allow true inferences to be made about a population from that sample. One of the aim or goal of sampling is that each individual on the population should have given equal chances of getting picked and getting involved or included on the sample, so that whatever you are getting from the sample will represent the entire population. So sampling now is a process used in a statistical analysis in which a predetermined number of observations are taken from a larger population. There are various sampling methods that allow all the units in the population to have an equal chance of being selected, and we are going to discuss it now. So we have said earlier that we wanted all of the individual within a population to have equal chance of getting selected and being included onto the sample, so that we can ensure whatever it is, the result that we are getting from the sample truly represents the entire population. So the first one is simple random sampling. So each element of the population has an equal chance of being selected. There are no rules that dictate where and how you will start the selection process, as long as you do not intentionally look for a specific number. Okay? So first we have a lottery method. Just like in Hunger Games, you know? you put all of the names of the population, you know, or the entire population. For example, if it's about people, then let's say all of the senior high school students from Davao City, for example only, you are going to get all of their names and then write all of these names into little pieces of paper, and then put all of these pieces of paper inside a big bowl maybe, or a jar, or something that you cannot see the number or any clue or hint about the names inside the paper. And then you will just, you know, pick different names one at a time. Pero syempre, kailangan mong maggamit ng Slovene formula so that you can get how many names you are going to get from the bowl. So Slovene's formula is, there's actually different forms of the Slovene's formula, but this is the basic one. So the sample size is equals to population size over margin of error squared times the population size. So that is how you get your sample size. So for example, if you have a 1,000 individuals within a population, and then your margin of error is 5%, or that is 0.05, then how are you going to get the sample size? You just have to use the formula. So 1,000 divided by 1,000 times 0.05 squared. And the answer would be 400. So ibig sabihin, meron ka dapat 400 people in your sample size. Now, using the lottery method, kailangan kang magbunot ng 400 katao doon sa iyong bowl. Okay? And whoever you have picked, those are the ones included onto your research study. Okay? Next, use of table of random numbers. This table consists of a series of digits, 0 to 9, that are generated randomly. The numbers are arranged in rows and columns and can be read in any direction. All the digits are equally probable. To give you an example of what a table of random numbers look like, it's like this. Okay, so for example, if you have more than 50,000 sample or population, then you can use this type of table of random numbers. As you can see, you can choose 21,564. So you have to list all of the names, maybe, no? For example, if you have a population of, let's say, all of the nurses in the Philippines. And so you have to list all of their names, ano, in alphabetical order ba yan? Ikaw nang bahala kung paano mo yan na-arrange. Basta meron silang number, right? Corresponding number ang pangalan. And so you try to close your eyes and then, you know, maybe a pen or a pencil. Tapos you have to say stop. And then kung saan nakatama yung ball pen. And then let's say 21,564. Sino man yung pangalan na nandoon sa 21,564, siya ay kasali sa iyong sample. Ganun maggamit ng table of random numbers. Now, this type of table of random numbers, predefined na siya, no? Gagamitin mo na lang. But there are also random number generator. Like, for example, if you have a minimum of 1 range, and then let's say you have 1,000 maybe, tawag dito, population size, and then you have to generate maybe 400 out of that. So let's calculate. So hindi mo na kailangan mag ganun sa table of random numbers. It will just give you the numbers already, readily, no? Without bias. And then, so whoever's name is on number 665 out of the 1,000, kasali siya sa sample. Yung pang 481, kasali siya sa sample. Pang 338, kasali siya. And so on and so forth until you reach the last or the 400th element in the sample size. Okay? So you could use this one as well. This is just one sample. There are a lot of other random number generator online. So you can just search it on Google. Next, we have systematic random sampling. Now, this can be done by listing all the elements in the population and selecting every kth element in your population list. This is equally precise as the simple random sampling. It is often used on long population lists and to determine the interval to be used in identifying the samples to who will participate in the study. You will use the formula K is equals to population size divided by sample size. So for example, guys, let's say I have 20 students. Well, in practical sense, I can include all of them, right? But just as an example, I have 20 students and I will only get 10 for my sample size. Okay? So, how will I get the kth element? So, sabi niya, no? The population size divided by the sample size. So, for this example only, 2 ang ating k element. Okay? So, ang kasali, by the way, this is taken from internet, no? Random names lang ito siya. So anyway, so how will I know who will be included in my sample? So ang ating K is equals to 2, right? So every second element, no, kailangan ko siyang isali sa aking sample. So let's start from this one. So 1, 2, Kalen is included. 1, 2, Maximus is included. 1, 2, Yasmin is included. 1, 2, Paige, 1, 2, Dylan, 1, 2, Marina, 1, 2, Dustin, 1, 2, Jamar, 1, 2, Damian, 1, 2, and then Audrey. So all of those are included in my sample, and they are going to be in the study. Okay? So going back onto the module, we have an example. If population is equals to 2,000 and the sample size is equals to 500, so K will be 2,000 divided by 500, or the fourth element, or every fourth element. So you can use a table of random numbers to determine the starting point for selecting every fourth subject, or you can do the same way that I did. You can start on the very top of the list. Okay? So with the list of 2,000 subjects in the sampling frame, go to the starting point and select every fourth name on the list until the sample size is reached. Probably we'll have to return to the beginning of the list to complete the selection of the sample. Depende. No? Basta every fourth element on the list will be included onto your sample. Now next we have stratified random sampling. This can be done by first dividing the elements in the population into strata, and then samples are randomly selected from each stratum, ensuring that each selected element is proportionately represented in the total population. So sampling fraction is equals to sample size over the population size. So let's have an example for this one. So let's say you have a 1,000 student with 500 from elementary, 300 from high school, and then 200 from senior high school. Determine how many samples you need, or you can use the Sloven's formula or any other formula for computing the sample size. Okay, so these are the given for the example. So, meron daw tayong 1,000 na estudyante at meron tayong 500 na elementary students, 300 na junior high, at 200 na senior high. So, earlier, we have already determined the sample size using the Sloven's formula, no? So, kinuha natin yung N by using this formula. Now, since we have 1,000 population, then our N is equals to 400. Now, paano natin malalaman kung ilan ang magiging sample natin dito na part, no? So, pwede natin kunin by dividing the sample size over the population size. So, that is 0.4. Now, once you get this, i-times mo lang siya dito. So, all of this, if you add, you're going to get 400. Okay, so ibig sabihin, dapat meron kang 200 na sample size from elementary, 120 naman from junior high, at 80 respondents from senior high school. So, that is the process of stratified random sampling. Guys, the stratum, depending on your study. Depende sa research study mo kung paano mo i-divide into strata ang isang buong population. It depends upon the researcher. Okay? So, last but not the least, on our types of random sampling, we have clustered sampling. A multi-stage sampling method adopted when it is either impossible or impractical to compile an exhaustive list of elements found in the target population. The whole population is subdivided into clusters or groups, and random samples are then collected from each group. So for example, sa cluster sampling, kung gusto nating malaman, no, for example, ang poll about presidential candidacy, and we want to ask all of the registered voters in the Philippines. So, hindi kaya, di ba, no? Napakaraming registered voters sa buong Pilipinas. So, you can cluster them. Like, let's say, for example, by region muna, no? And then, after by region, siguro by province, tapos by congressional district siguro, sorry, hindi. Tapos by congressional district siguro, no? And then, siguro, by city or municipality. And then, pwede rin siguro hanggang barangay, no? So, para magliit ng magliit, at hindi ka masyadong mahirapan kasi napaka-impractical kung lahat, 'di ba, ng registered voters ay tatanungin mo about a poll, about the presidential candidacy. So, you have to sample them and you can use cluster sampling, okay? So, you can do this one. And there are other examples that you can use cluster sampling, especially in educational researches kung saan gusto nating tingnan ang overall English fluency ng buong student population in the Philippines, or maybe reading comprehension, you know, all of these things. You can use cluster sampling para hindi tayo masyadong mahirapan. So going back to your module, you have an example here. A researcher wants to survey about academic performance of high school students in the municipality of Cabacan. He can divide the entire population into different clusters, like barangays. Kasi nga medyo malaki-laki rin ang Cabacan, at madami ang magiging respondents niya kung isasali niya lahat ang buong population ng high school students in the municipality of Cabacan. Now, the researcher selects a number of barangays depending on his research through simple or systematic random sampling. The researcher now could draw random samples from the selected barangay through simple random sampling or take them all. Depende. You know? So, clustered sampling, after mo siya i-cluster, gagawin mo pa rin ang either simple random sampling or even systematic random sampling. Depende sa'yo. Okay? So, ang part ng clustered sampling is just a beginning, no? Kung baga pa, mauuna lang siya na proseso kasi nga pinapaliit mo yung sobrang lawak na scope ng iyong population. Okay? So, those are the 4 sampling techniques that we can do. And next, we are now going to talk about parameter and statistic. Okay, so you have heard of this, I'm sure. You have heard of this in your junior high school. So let's try to analyze this. Study the cases below. Identify which of the cases involves measures from a population and a sample. Case 1. A researcher randomly selected a sample of 1,600 people in Davao City and asked if they use a certain detergent brand, and 40% of them said yes. Case 2. A researcher interviewed all the members of the mathematics department with 10 female teachers, 15 male teachers, and 1 department head. He wants to know the average hours per day they spend in training students for competitions and found out that they spend an average of 2 hours per day for training. Okay? So if you're going to look at the cases, in the first case, the researcher is actually using a sample because only 40% of the 1,600 people in Davao City were asked. Okay? And also because of the words that randomly selected a sample. So it is obvious. Okay, case number 2, it is obviously population because all of the members of the teachers within the mathematics department were asked. Okay? So just to give you the formal definition, a measure that describes a population is called parameter. A measure that describes a sample is called statistic. Okay, so in parameter, we are talking about the population. And when we are talking about sample, then the measure we are talking about is also statistic. Okay? So the main difference is that in parameter or population, if you are talking about the mean, then we represent them by mu. And in statistic, it will be represented by the X bar. Now, the variance in the population is going to be represented by sigma squared. And in the statistic, it is going to be S squared. Now, for the standard deviation, it is going to be sigma for the parameter, and in the statistic, it is S. So these are the differences between these two. But the main difference is that parameter, we are talking about the entire population. And if it's statistic, then we are talking about the sample. Okay? So going back to your module, let's have an example. So let's say for a parameter, 50% of the 24 Philippine senators agreed to support a certain measure. And for statistic, a researcher found out that 25% of the students in the Philippines reported to have internet connection at home. So obviously, ang first part, no, itong 50% of the 24 Philippine senators, it is obviously parameter because we only have 24 senators in the Philippines. So kung lahat sila kasali, nung nag-agree or nagbutahan about a certain measure perhaps, no, maybe a bill or a law, then it is indeed the entire population. And therefore, we are talking about parameter in this case. On the next part naman, only 25% of the students in the Philippines reported to have internet connection at home. This 25% is taken from the entire population, which is the population of all the students in the Philippines. Okay? So in that part, meaning we are only talking about the sample from the entire population. Okay? So depending on your research study, it depends no kung ano ang kailangan mong kunin. It might be the parameter, it might be the statistic. Different ways and different factors or reasons, depende talaga ito sa researcher kung ano ang gusto niyang gawin, kung ano yung objective ng research study niya. Merong mga times na kailangan parameter ang pinag-uusapan. Buong population dapat kasali, no? Pero meron ding times na it is impractical. It takes a lot of time, takes a lot of effort, takes a lot of money, no? So, kailangan sample lang yung isasali natin sa ating research. Now, later on, we will be talking about lesson 3 up to 5, which is sampling distribution of the sample means, the central limit theorem, and we will try to solve some problems involving sampling distribution of the sample mean. So thank you so much for watching this video lesson, and see you later on the part 2 of this video lesson. Subhanakallahumma wa bihamdik, ashhadu an la ilaha illa ant, astaghfiruka wa atubu ilaik. Assalamu alaikum wa rahmatullahi wa barakatuh.